Question 21 on the final exam is from section P.3, previously tested on exam 1, number 9. Student will be able to solve multi-step linear equations in one variable. Directions say solve the equation for x. So we begin with some distributive property. Resulting in 3x minus 12 minus 2 equals 2x plus 18 plus 2. Now I'm going to combine like terms on each side respective, giving me 3x minus 14 equals 2x plus 20. I'm going to bring my 2x to this side, my negative 14 over here. So let's see, I'm going to have to subtract 2x, giving me x. I'm going to have to add 14, giving me 34. And that's solved for. Next one, I'm again going to begin with some distributive property. A lot of students might make the mistake of combining the 3 and the negative 2 together first and getting 1. But the negative 2 needs to distribute inside the parentheses. Here the 3 distributes. So we get 3 minus 10 plus 4x equals 3x minus 6 minus 7. I'm going to go ahead and combine my like terms, giving me negative 7 plus 4x equals 3x minus 13. I'm going to bring my 3x to this side, my negative 7 over here. So let's see, the 3x is going to get subtracted, giving me x all by itself. The negative 7's got to change to addition, giving me negative 6, and finished. Question 22 on the exam from section 2.6, previously tested on exam 3, number 5, is going to see if you know how to find the location of any vertical asymptotes of rational functions. Well, it's important to know and understand, to solve a problem like this, that vertical asymptotes come from the denominator. We want to know, where does the denominator equal 0? And so I'm going to take my denominator and I'm going to re-express it in a factored form. X plus 6, x minus 2, set it equal to 0, would solve to give x equals negative 6 and x equals 2. And those are the vertical asymptotes. In this next problem, we're again looking for the vertical asymptote. It again comes from the denominator. We set the denominator equal to 0 and solve for x. We get x equals negative 7. And that's it. Question 23 on the final exam comes from section A1. Again, the first section of the year, tested on exam 1, number 3B. I want you to be able to simplify radical expressions that involve sums and differences of radical expressions. So how do we add and subtract multiple radicals together? Directions say simplify the radical expression. We begin by needing to completely simplify each individual radical. The first one, 96, is 16 times 6. 50 is 25 times 2. And 150 is 25 times 6. Now all of the perfect squares come out. Okay, so 16 comes out as 4. 25 comes out as 5, and we'll multiply the 2 that's already there, so that makes 10. 25 comes out as 5. and we're here. Now we can only add and subtract the ones that are alike, and by alike we mean have the same number underneath the square root. So we get this 10 square root 2, and 4 minus 5 is negative 1 square root 6. Alright, next example of the same directions. The first radical simplifies 147. We would need 49 times 3. 98. We would need 49 times 2. And 643, we would need 81 times 3. So it's the perfect squares that come out. Okay, so we're going to begin with 12 times 7, as that's the perfect square, 49. 12 times 7 is 84. Now we're going to need 4 times another 7. So that's 28 square root 2. And then we're going to need 6 times 9. So we get 54 square root of 3. And now any of the alike radicals, which are the square root of 3's, can be added together. 84 plus 54 is 138 square root 3, and we have that 28 square root 2. Question 24 on the exam from section 2.8, previously tested on exam 3 number 10. We'll see if you can solve rational inequalities, answers expressed in interval notation. This is probably one of the harder skills on the final exam historically, maybe just from the point of view that it requires a lot of work, a lot of meticulous work in order to answer the question correctly. So I'll show you a couple examples step by step in how to do this so that hopefully we can get this one right. First thing we're going to need to do is to completely factor all numerators, all denominators, if they aren't currently factored. So I rewrite the problem so that the denominator factors x plus 2, x minus 2. Okay. Now what we're going to do is get the zeros from the numerator and the zeros from the denominator. So we get x equals 1 from the top, we get x equals negative 2, and x equals 2 from the denominator. So we're going to get all 3 of those points in this particular problem. I'm going to take these 3 points and I'm going to locate them on my number line. So negative 2 comes first, then 1, then positive 2. Now, all points that come from the denominator of the fraction are always going to be open circles. So at negative 2 and at positive 2 is going to be open. The point from the numerator, this point here, can be open or closed. And that depends on the inequality. The inequality does not have an equal to, so therefore it can be open. And now I'm going to do a sign chart analysis to determine where I'm going to shade on this number line. For example, if I pick any number that's out here bigger than 2, say I pick x equals 3, and I substitute that 3 in for all the x's. X here, and here. So it's going to be 3 minus 1. 3 minus 1 is a positive number. In this parenthesis, 3 plus 2 is a positive number. And in this parenthesis, 3 minus 2 is a positive number. 3 positive numbers make a positive number. I want numbers that are less than 0, and less than 0 numbers are negative, I got positive, so therefore I don't want this area of the number line. Next I'm going to pick something between 1 and 2. Say 1.5. Okay? So 1.5 minus 1 is a positive number. 1.5 plus 2 is a positive number. 1.5 minus 2 is a negative number. 2 positives and 1 negative will multiply and divide to negative. I want negative numbers, so this area of my number line will get shaded. Okay, next area is between -2 and 1, so maybe we choose 0. 0 minus 1 is negative. 0 plus 2 is positive. 0 minus 2 is negative. 2 negatives make a positive. With that positive are going to be positive. And I don't want that, I want the negative. And finally out here, maybe we choose -3. -3 minus 1 is negative. -3 plus 2 is negative. -3 minus 2 is negative. 3 negatives make negative. So we're going to shade where it's negative. Okay, so our interval solution answer will be -infinity to -2, 1 to 2. And that's it. Alright, one more example of this type. This one already begins completely in a factored state, so I can go ahead and grab all my x equals. Get x equals -2 from the top, get x equals -3, and x equals +3 from our denominator. And on our number line is going to go these 3 values. So first we'd get -3, then -2, then +3. Okay, now as far as the open and closed circles go, my denominator points have to be open because we can't be those numbers. The numerator point can be open or closed. In this case it's going to be closed because the inequality has an equal to. Alright? Now we're going to start testing, determining where we're going to shade. So I'm going to begin, let's start on the left this time. Maybe I try -4. And so -4 plus 2 is negative. -4 plus 3 is negative. -4 minus 3 is negative. 3 negatives are negative. And this time I want numbers that are greater than 0. I want positive numbers on this particular problem, so I don't want this negative part of the number line. Okay, so let's move between these two. Let's try -2.5. -2.5 plus 2 is negative. -2.5 plus 3 is positive. -2.5 minus 3 is negative. That's 2 negatives. That makes a positive every time. So we want this area of the number line. Okay. Keep going. I keep testing. I'm going to go a little faster. X equals 0. 0 plus 2 makes the numerator positive. 0 plus 3 is positive. 0 minus 3 is negative. That's negative. We don't want it. I'm going to test out here 4. 4 plus 2 makes the numerator positive. 4 plus 3 is positive. 4 minus 3 is positive. All those positives make positive. We want positive things. Shade that area. So our solution is -3, -2 with a square bracket on the -2 and 3, infinity. And we've got it. Question 25 on the final exam comes from section 1.7. It's previously tested on exam 2, number 22. This question is going to test if you can set up and solve mixture problems using systems of linear equations or just linear equations. I suppose we don't really need systems if we don't want to use them. I'm going to show you an algebraic way to do this, and then I'm also going to show you the shortcut Pearson square that some of you picked up on and seem to like very well. So I'll show you one example of each. Alright, this question says how much 10% solution and how much 45% solution should be mixed together to make 100 gallons of a 25% solution. So we are mixing together 10% and 45%. We want 25%. Now we have 100 gallons to make. Well, of that 100 gallons, we're going to put some of it here. We're going to put the other of it here, the remainder of it here. I'm going to say the remainder of it is the total minus what I put into this quantity. So our equation could be 10%, so 0.1x plus 45%, 0.45 times 100 minus x equals 0.25 times 100. And we solve this equation for x. So we have 0.1x plus 45 minus 0.45x equals 25. Combine the x's, I've got negative 0.35x equals, I'm going to take this 45 across, so negative 20. And 20 divided by 0.35 is going to give me an x of 57.14. Okay, so that's 57.14 gallons of 10%. Well, now I need to know how many gallons of 45%. And since there are 100 gallons total, we just need to subtract 57.14 from 100 gallons, leaving us with 42.86 gallons of 45%. Alright, in this other example, I'm going to show you the Pearson square technique. Let me write this down in case you want to look it up online. I'm going to show you Pearson square. Pearson square solves these mixture problems very easily. How much 25% should be added to 90% to make 150 gallons of 70%? So let's look at the percents first. We've got 25, right here, 25% and 90%. That's what we're mixing. We want 70%. So I'm going to take, on this line, I'm going to subtract. 70 minus 25 is, let's see, 70 minus 25 is 45. I'm going to subtract here, 90 minus 70 is 20. What we want to do is add these two parts together, giving us 65 total parts. Okay? What we've got at the end of these lines are the parts out of 65. I've got that 20 over 65, which reduces to 4/13. 4/13 of my total should be the 25%. And here we've got 45 65ths, which reduces to 9/13. 9/13 of my total should be the 90%. So I should have more of the 90% than I do the 25%. Well, how much exactly? We want 150 gallons. So what I'm going to do is take these ratios, 4/13 times 150, 9/13 times 150. And if I do those, let's see, the first one is 46.15, we'll say gallons of 25%. And if I multiply this one, I get 103.85 gallons of the 90%. And there's your Pearson square technique to do these mixture problems. The result is the same as far as finding the answer goes. One using symbolic algebra and the other just this numerical Pearson square approach. And again, it's your decision as far as to how you're going to work this problem out on the test.